Hey guys, in today's video we are going to find areas of triangles and parallelograms and two special types of parallelograms, rectangles and squares. Okay, so in a parallelogram you have bases, and bases are either pair of parallel sides, and I'm going to use the symbol for parallel. Either pair of parallel sides are bases. Okay, so right here, this is a parallelogram, and I've got a pair of parallel sides here. Those are bases. So I can use those as the bases. I could also use these as the bases instead, this pair of parallel sides. The height of a trapezoid is the shortest distance between bases of a parallelogram. The shortest distance between bases, that shortest distance is always perpendicular to a base. Shortest distance between bases will always be perpendicular to a base. In fact, it'll actually be perpendicular to both bases. So here is a height. It is perpendicular to both bases. Okay, or I could have the height outside here. So if I continue this base, it would be perpendicular to that base and that base, so I can use that as a height. Now I could also say that because these are parallel, I can use these as bases. And if these are the bases that I'm going to use, then I would use this perpendicular segment as a height. It is perpendicular to this base, and if I extend this base, it's perpendicular to that one as well. Okay, so the height that we use has to be perpendicular to the two corresponding bases. Alright, so an area of a square. The area of a square is the square of the lengths of its side. Okay, so the area of a square is side squared. Now, something we should make note of is that if two squares or any polygons happen to be congruent, then they will always have the same area. So if we find the area of a square and say there's another square that's congruent to it, we know that that square has the same area. Or if we want the area of a region that's made up of two different squares or two different polygons of any kind, the area of that region will be the sum of the areas of the non-overlapping parts. Okay, so that's something we'll come across later on in this lesson. Now back to areas. The area of a rectangle. It is the product of its base and height. So that means you multiply base times height. So the area of a rectangle is base times height. A parallelogram is also the product of its base and its corresponding height. So for a parallelogram, you will multiply base times height. Now, square is a type of parallelogram, but we went with side squared instead of base times height. Okay, now we could actually say the area is base times height, but in a square, the base and height happen to be the same. Okay, so if we just multiply it by itself, that is the same as squaring it. Okay, and the last area formula we'll get here is the area of a triangle, which is half the product of its base and height. So it is 1/2 base times height. Okay, so we're going to find both perimeter and area of quadrilateral or of parallelogram PQRS. Okay, so in order to find this area, if I tilt it this way, I've got a 12 here as a base, and its corresponding height is 4. Okay, so I can use 12 as the base, 4 as the height, so the area is 12 times 4. Okay, so if I pull out my calculator here, 12 times 4 is 48, so I get that the area is 48 units squared. Okay, now I can use the 12 and this 12 opposite it as the bases, with the corresponding height being 4, or I could use 6 So I would have 6's as the bases. So I could say the area is a base of 6 times, and then the corresponding height to that 6 is what's perpendicular to it, which is 8. And 6 times 8 is also 48. So either way, I get the area is 48 units squared. Now the perimeter is the sum of the four sides, 12 plus 12 plus 6 plus 6. Okay, so 12 plus 12 plus 6 plus 6 is 36. Okay, and that would be 36 units. So perimeter is units, area is units squared. All right, find the perimeter and area of each of these polygons. Okay, so the perimeter of this triangle is 17 plus 10 plus 21. And that is 48. So 48 units is the perimeter. Now the area is 1/2 times the base of the triangle times the height. Okay, now the height, that's this 8, and the base is what's perpendicular to it, and that is 21. So 21 times the height, which is 8. So 1/2 times the base times the height, and that is 84. And because it is an area, it is in units squared. Okay, next we have a parallelogram. So the perimeter is 30 plus 20, and then over here's another 30, and here's another 20. So plus 30 plus 20. Now that's 50 here and another 50 here. That's going to add up to 100 units. Then the area of a parallelogram is base times height. Okay, so I need a base and height that are perpendicular to each other. That would be 30 and 17. 30 is the base, 17 is the height. 30 times 17 is 510. 510 units squared is the area. Okay, now our last one on this page, the perimeter is 5 plus 13 plus I don't know what. So in order to get this, I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. A and b are the legs, 5 and we'll just call this one x. 5 squared plus x squared equals 13 squared. So I'm going to subtract 5 squared from both sides. X squared equals, okay, now it's not the same as just doing 13 minus 5 and getting 8 and then squaring that to get 64. So don't do that. 13 squared minus 5 squared is 144. Okay, order of operations says we can't just subtract these numbers and then square it. The squaring takes place first. Okay, now the square root of 144 is 12. So this third side here is 12. So 5 plus 13 plus 12 is the perimeter. And that is 30 units. Okay, now the area of the triangle. It's a triangle, so it's half times base times height, and the base and height must be perpendicular to each other, and that is right here. So the base and height are 12 and 5. So it's half times 12 times 5, and we get 30. Okay, so we have a case here where the perimeter and area happen to be the same. All right, the base of a triangle is twice its height. Okay, so we have a triangle where this base, we'll call the height x because it's the shorter one. The base is 2 times the height, so we'll call that 2x. Okay, so now we want to find the height of this triangle. We want to find the base and the height of the triangle, knowing that the area is 36 square units. So the area formula is area is 1/2 base times height. So I know the area is 36, and that equals 1/2 times the base is 2x, and the height is x. Okay, now let's simplify this. 1/2 times 2 is 1, so this actually simplifies to 1 times x, and x times x is x squared. So this is really 1x squared, or x squared, equals 36. Now when I take the square root, in an equation like this, technically I actually get a positive and a negative square root, so it's plus or minus 6. But this is a length of a part of a triangle, so plus or minus doesn't really make sense here. It has to be positive 6. So 6 is the value of x. So the base and the height. The height is x, and x is 6, so the height is 6 inches. The base is 2 times x. 2 times 6 is 12, so the base is 12 inches. You need to buy paint, so you can paint the side of a barn. A gallon of paint covers 350 square feet. How many gallons should you buy? So what we need to know is what is the area of this side of the barn. Okay, so we're going to find areas of 2 non-overlapping parts and add them together. So we have a rectangle here. So for the rectangle, the area is base times height, and they have to be perpendicular to each other, 26 and 18. 26 times 18 will give me the area of that rectangle. So 26 times 18 is 468. So 468 feet squared is the area of the rectangle. Now the area of the triangle. Okay, so what I have here is a right triangle, so there's a right angle right here, and it's isosceles, so it's actually a 45, 45, 90. So I'm going to redraw that down here. These are congruent. This is a right angle. This here is 26 feet. Now in a right triangle, our ratio, and I'll just call this x, is 1, 1, root 2. Okay, so these two are the same. So if this is x, then this is x, and I've got a ratio of 1, 1, root 2. So x is to 1 as 26 is to root 2. Okay, so I need to multiply top and bottom here by root 2. So I get x over 1, which is just x, equals 26 root 2 over, and then root 2 times root 2 is 2. And this simplifies. 26 over 2 is 13, so 13 root 2 is my simplified side length on this part of the triangle. Okay, now that means this one over here is also 13 root 2. The area of a triangle is 1/2 times base times height. And the base and height have to be perpendicular to each other. And these are perpendicular to each other, so I can use these as my base and height. So for the triangle, the area is 1/2 times the base times the height. Base and height. 13 root 2 times 13 root 2. Okay? So I've got 1/2, and I'll just put that in as 0.5 times 13 times 13 times, and then root 2 times root 2 is the square root of 4, which is 2. So root 2 times root 2 is 2, so I'm going to multiply by 2. And that is 169. So the area of the triangle is 169 feet squared. Okay, now if I add these two together, 169 plus 468, I get a total of 637 feet squared that I need to paint. Okay, so if I'm going to cover 637 feet squared and each gallon covers 350 feet squared, how many gallons do I need to buy? So I'll do 637 divided by 350 for each gallon. So 637 divided by 350 is 1.82. 1.82 gallons. That's what I need to use. Okay? Now, you don't go to the store and buy 1.82 gallons of paint. So when I go to the store, I'm going to have to buy 2 gallons. A parallelogram has an area of 153 square inches and a height of 17 inches. So here is a parallelogram. Its area is 153 inches squared. Its height is 17 inches. What is the length of the base? Okay, so the area of a parallelogram is base times height. The area here is 153. The base is x. The height is 17. So I'll divide both sides by 17. And I get x is 9. Okay, so what is the length of the base? It is 9 inches. Okay, so suppose there is, in this barn, a 5-foot by 10-foot rectangular window on this side of the barn. So there's going to be a window right there. That doesn't show up very well. Let me get a different pen. Let's see if that'll show up a little better. So we're going to put in a window right here. And that window is 5 by 10. Okay, now what is the approximate area that you need to paint? Okay, so we had 637 square feet to paint. And now we're not going to paint this window. Okay, so for that rectangle, the area is 5 times 10, which is 50. Okay, so there's 50 square feet that is not going to be painted. So we're going to take this total of 637 and subtract that 50. And now we've got 587 square feet. Okay, so that answers that question, but I want to know now, how much paint do I actually need to buy? So what if we did 537 divided by 350, since 350 is what 1 gallon will cover. So 537 square feet divided by 350 square feet. Now it's 1.53 gallons of paint. Okay, now paint comes in gallons or half gallons. You can buy a quart. I could buy a gallon and a quart. It doesn't come in half gallons, it comes in quarts. So a gallon or a quart. So I could buy a gallon and 3/4, but a quarter gallon is kind of expensive. So by the time I've bought 3/4 of a gallon, I might as well buy all 2 gallons. So we're going to buy 2 gallons of paint still. Now we skipped some stuff on the front page. That's some review of things that we've learned previously. So let's go back there and finish this up. Okay, so give the indicated measure for circle P. The radius, how long is the radius? It is 3. If the radius is 3, then the diameter, which goes all the way across, is 6. And then the measure of arc ADB, so from A all the way to B, but it has to go through D. If there was no D, it would just be AB. We would go the shortest way. But this says go through D, ADB. That is almost the entire circle. It's the whole thing except for this 70. So we're going to do 360 minus that 70. 360 minus 70 is 290. So the measure of arc ADB is 290 degrees. Use a formula to find the width of a rectangle that has a perimeter of 24 centimeters and a length of 9 centimeters. Okay, so we've got a rectangle. and it has a length of 9 centimeters. We want to know the width when the perimeter is 24. So the perimeter is length plus width, or we can call it 2 times the length plus 2 times the width. And we have a length of 9 and a perimeter of 24. So 24 equals 2 times 9 plus 2 times whatever the width is. Okay, so that's 18. So if I subtract 18, I get 6 equals 2W, and divide by 2, I get that the width is 3 centimeters. In triangle ABC, C is a right angle. Use the given information to find the length of AC. Okay, so here we have triangle ABC where C is a right angle. And then we have A and B. So AB has a length of 14. BC has a length of 6. Find the length of segment AC. We can use the Pythagorean theorem for this. A squared plus B squared equals C squared. So we've got 6 squared plus B squared equals 14 squared. Minus 6 squared. B squared equals 14 squared minus 6 squared is 160. Okay, now that is not a square number, but it is 16 times 10. 16 is 4 times 4. There's a pair. 10 is going to be 2 times 5, and I'm not going to get any pairs out of that, so I'll just leave that 10 right as it is. Or I could do 2 times 5, which is going to make 10. So I'm going to pull out a 4, so B is 4 times the square root of 2 times 5, which is 10. Okay, so that is actually the length of segment AC. So I'm going to say equals AC and put a box around that. Okay, so we've got the same triangle with C as a right angle and then AB. This time the measure of angle A is 35 degrees and AB has a length of 25, and we want to find the length of AC. So I'll call this X again. So this time I'm going to use SOHCAHTOA. Okay, so I've got the adjacent leg and the hypotenuse, the opposite leg from this 35. That opposite leg is blank, so I'm not using opposite leg. I'm using adjacent leg and hypotenuse, and that is right here in CA. So I'm going to use cosine 35 degrees is to 1, as the adjacent is to the hypotenuse. X is to 25. Okay, so I will cross multiply, and I get X equals 25 times cosine 35. So we have 25 cosine 35, and that is 20.48. And that is the length of segment AC. Okay, and our last one in this row, we have the triangle again with C is a right angle, and then AB. This time B is 60 degrees. BC is 5, and find the length of AC, so I'll put my X there. Okay, so this time I have a 30, 60, 90 triangle, and in a 30, 60, 90, the shortest is 1, longest is 2, and the remaining side is root 3. So I've got 1, 2, root 3. So X is to root 3 as 5 is to 1. Okay, since I have a variable in the numerator here, I can just take what's under it and multiply it across. And I get 5 root 3 over 1, but I don't need to write over 1. So 5 root 3 is the length of segment AC. Which special quadrilaterals have diagonals that bisect each other? Bisecting diagonals, that happens in a parallelogram. And if it happens in a parallelogram, then it happens in every type of parallelogram, which includes rhombus, rectangle, and square. Okay, the other types of quadrilaterals, the special quadrilaterals, are kite and trapezoid and isosceles trapezoid, and none of them have diagonals that bisect each other. And last, use a proportion to find the length of xy. Okay, if these triangles are similar. So I can say 5 is to xy as 8 is to 12. Okay, now this time I don't have a variable in the numerator like I did here, so instead of multiplying across like I did here, I will just do cross products. So I get 8 times xy equals 5 times 12, which is 60. Okay, and then I can divide by 8, and I get the length of xy is 60 divided by 8, and that is 7.5.